Hey everybody, it's Tyler here at the Texas Cup. I'm checking out team number 118, the Robonauts. Of course, amazing team that we have here. Can't wait to talk more about this modified 2020 robot that they have. And to help me do that, I have Ashton, Casey, Rishi, and Esther. And we're gonna be going through that course, that whole power cell journey. Check out the really cool climber that they have. And a cool control panel mechanism that's been updated. All this and more coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com and let's get your team scheduled to be on First Updates Now.
So Ashton, start us out on this robot here. Will take us through the power cell area, starting with the intake. Love to hear about, of course, any modifications you made from 2020 into 2021 as well. So start us out here with the intake.
So we just have 3 rollers covered with surgical tubing, but this intake is actually deployed by a rack and pinion mechanism over here. So the pneumatic deploys and it creates a rotational motion by deploying the rack and moving the pinion to deploy it. So the ball comes in from the bottom. Well, there's the rack. And then the ball comes in. And it comes straight up, and we use this back wall back here to bring the ball up so we can go into our next subsystem, which is the hopper. The hopper just stores the balls where we have these pneumatics here that agitate the balls to stop any jams that we may see in matches, and especially not running over the rendezvous throughout the match.
So when you guys are intaking, I'm going to assume this is actually down when you're intaking,
yes.
So it's just hitting that and going back in?
Yes.
How did you come up with the concept of doing the rack and pinion for the intake here?
So we were really looking for something that would allow us to stow this large of an intake into where we needed to be. So this robot was really started the design with a shooter. We had to design the intake around the rest of the robot, so we had to create the rack so that way we could stow and deploy. We also wanted to be able to bring in the intake if we needed to play like defense or not, jam the intake against walls or stuff like that.
So let's head over to Casey here, who's not only building muscle by carrying this very large, what you call the intestine for your robot. So tell us a little bit more about this whole device and how it works.
Okay, so moving on to the intestines, it's a little harder to see, so I brought out our extra right here.
You didn't just rip it out of the robot for us? Okay. Just making sure.
I would do that for y'all, though, don't worry. So up top, you can see it's powered actually by this Falcon down here. And that goes through a belting system that goes up to the top, which is all really loose belts, kind of as you can see, and it's all belt tensioned with these spacers on screws. So the way it's a clutching intestine system. So the way this kind of works is we have a aluminum tube on a PVC pipe, and this all of the springs you see have it tensioned downwards, right? And there's also that frictional tension within the PVC and the aluminum itself. So balls, this is where in the robot where the kicker starts for the shooter. So the balls stop right here. Let me see a ball. The balls stop right here. This keeps spinning, right? But these stay right where they are because of that tension. They just spin. And come here, Rishi. Those don't go anywhere. Right? These balls stay exactly where they are.
So what actually allows it then to go into the shooter? Like what process happens for that?
So there's a button that's pressed and the kicker starts rolling its Omni wheels and it goes straight into the kicker. We did this to prevent jamming. We did a lot of different iterations with the intestine system, and we decided on this because of so little jamming.
Sure, and I mean, obviously been working out quite well, so I appreciate the breakdown on that. Rishi's going to be going more into the shooter of your robot. So of course, Robonauts known for having fantastic shooters over the years. So tell me a bit more about the shooter, turret, hood, all the good stuff. Really interested to hear more about your flywheel as well too, Rishi.
So yeah, going to the shooter where we have right here, it all starts coming down from the intestines where we have our kicker motor, which is going to be a little tight to see, but it's basically run by a Neo 550 and it's going up a upward slope. So as soon as we say that we want to shoot, the kicker motor goes to full speed and the balls start flowing straight in a line. Like you can see some of our great robot streams, ball streams that come out of the robot. From that, you also have the turret and then the shooter. So this is a double wheel shooter with a double wheel shooter with the top wheel right here. There you go. Ash, can you help me out here? So you can see right here we have 3-inch Coulsons at the top that are run by a Neo 550, and we also have another Neo 550 that gives us about 80 degrees of range on our shooter. Sure. This helps us let us do that really close shot in that triangle, but it also lets us shoot from behind the control panel and still get all outers. And a lot of the prototyping that we did, we saw that this top wheel giving a lot more inertia into the balls was getting rid of a lot of the different types of balls. So if we had some damaged balls or not so damaged balls, we're easily able to work through that. We also have 2 inertia wheels on this shooter. We have one on the top that we like to call the baby inertia wheel, which helps keep the speed by also keeping a light shooter, while we also have one right at the bottom of the shooter all the way right here. Very similar to our 2017 inertia wheel, which we also knew worked really well. So this allows us to keep a very light main wheel. This main wheel right here only weighs half a pound.
Oh wow, okay.
Yes, but with this 1.5 pound inertia wheel, we're able to get so much inertia that we're still able to shoot all 5 balls with great accuracy.
Well, and not to mention too, having those extra kicker wheels come in allow your shooter not to lose as much speed, right, coming in, so that they're going to allow you to just keep going that way. Now, I got to ask you the functionality of the blind light here.
So the blind light is just something we like to use in the pit when we just have some trouble with the limelight, just so the light doesn't go into some of our teammates' face. Yeah.
So can you take us into the control panel mechanism we have here? This is probably one of the what we call beefier mechanisms we've seen for control panel. So tell us a little bit more about it.
So as much as a lot of people like to make fun of us having this beefier mechanism, it's actually one of the greatest control panel mechanisms that I've seen on any robot. We're able to come at any angle from the trench when we're going through our cycle and still be able to spin it. So as the driver, it's been very appreciative having such a big one. But even though it's really big, it's still very light, weighing under 5 pounds, which some people might say is heavy, but it's completely worth it with the amount of points that you're able to get with it.
Well, and you're having that dual functionality, right? When this is down, this is also keeping the power cells in, too, so I like that a lot. Let's wrap up on this robot here, talking, Esther, in regards to the climber up on here, obviously a telescoping climber that we have, but break it down a little bit more for us.
Okay, so I'm going to quickly explain this climb system and then get our driver Rishi to run it up and down for y'all. So we have kind of a unique actuation system for our climber. If you take a look over here, you'll see industrial grade fish tape wrapped up on a reel. This is just steel tape, 1/4 of an inch wide, and we have it wrapped up on this reel here. Whenever we unwind this reel, there's tape that feeds through these tubes, connecting inside the tubes to these hooks. And by reeling out, the hooks go up, and they just support the weight of the hooks, this little bar, and the weight of the tubes. When it goes down and collapses, the fish tape reels back in and pulls up the entire weight of the robot. This whole system is powered by a single Falcon, but it's still really fast. You can see that Falcon right over here. We have a shaft down in the middle that connects both sides. I actually have a spare tubes right here with me. Rishi, if you could help me out by holding this mic. So regarding changes that we made since 2020, we had to work with a lot of reinforcement for these bushings here. So you can see I have these bushings at the top and also in the bottom that helps with the stack up of these telescoping tubes. These are laid out of Delrin. We experimented with 3D printing, never quite strong enough, so these are made out of Delrin and super strong. And if you look in the inside, we have some reinforcements where we had these bolts that drilled in and shaved off the heads that act as studs almost, so that whenever this thing takes load, in order for the bushings to break off, they would have to shear through the actual Delrin. So
yeah, let's see it demonstrated and actually show how it goes
Rishi will run
Very
it up and
excited to
down.
see that.
And we can climb at any height.
Yeah, say it one more time. I really want to get closer to the gears here. So this pneumatic they have in here, that's just engaging it, right?
So we have one pneumatic attached to this brake on this one side, on the motor side, and whenever we go up, we have this thing that engages with the gear. If you ever watch us climb, you'll notice that once we go up, we don't back down. Even after we disable and disconnect, we have to have our people pick it up off of the bar. We have this brake there so that it never has the accident of falling down, so that we mitigate the risk of us falling off the bar.
Well, 118, thank you so much for taking the time to speak with us about your robot. Always great to see how some of these awesome tier teams are being created, and your team never disappoints with that. So thank you once again for really doing a great job explaining as well, too, so other teams can see it and learn. And can't wait to see how the robot performs here, of course, but as you lead in the future seasons, what else your team comes up with. Thanks a lot.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow, join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.